Hi everyone, I am Jenny, and I feel like it's very not fair to go after Charlie because I don't know how to juggle. So please accept me as is, but I will try to juggle with words, but usually that means that I'm gonna stutter, so please be kind. I want to share with you my quick research. I am actually a developer relations, but I am a weird kind. I'm the one which likes to do research and development tasks. And I am the one who is more interested in the part of retrieval and the relevance of retrieval. I work in the vector search engine. Quadrant was mentioned today in the good and the bad. And I like to research on the part of search relevance because just returning the semantically similar vectors doesn't mean that you get the relevant results. And I like to research mechanisms or tooling to make your results more relevant at scale. And one of the problems that we have with vector search is that, but honestly with every search, that if we would perfectly formulate a query and we would know what we're exactly searching for and we would know what is exactly relevant to our result, we wouldn't be creating a conference here, right? The problem is that usually query is badly formulated, desired documents, we don't know the shape of our data set that is stored there somewhere in the embedding form. And it also, we're using at scale usually for retrieval pretty simple, cheap, dense models. And as we already heard today, that dense models themselves need a little bit of help to retrieve the relevant results. So a very common problem is that on the first step of retrieval, person comes with their black rag magic and they're like, okay, I want to get the result, I want to get the chunk of my document to my query. And the query shoots somewhere in the vector index, somewhere in the random place in the space, and it's absolutely not close to the desired document. The person looks at this garbage, LLM looks at this garbage, tries to generate the right answer, doesn't, person gets a little bit sad, and then we try to find a way to solve this problem. And usual approaches, I would say to either maybe try to adjust the query, or the one that I'm going to talk about today is to adjust the rescoring function itself to take in the feedback. And what I mean about the feedback is that a very smart model, not the simple dense retriever that we're using, but a very smart model, or a human, if you would show them the whole collection of documents that you have in the store, it would certainly say, okay, this is the best answer. But our simple dense retriever doesn't know it. But it can provide some results that it retrieved to this smart model. And the smart model can say, well, this is kind of relevant to what you're asking, what is the user asking, and this is not that much relevant. And based on this feedback, we can adjust the query, or we can adjust the scoring function. So adjusting the query would be to change the embedding and try to shoot again in the space, but closer to the document. And adjusting the scoring function, which is in our case, would be using our HNSW index, which we use, or any other vector index, is to adjust the direction in which we're traversing the index to find the relevant document. So I tried to create an analogy which will help to understand what I'm talking about, because it's a little bit complicated until you know what is the index and everything. Imagine you're lost in the forest and you have very, very bad mobile network, but you have a person who is very good at forest orienteering. And the very bad mobile network allows you to send them a couple of photos. You can send a couple of photos, say the photo on the right, the photo on the left. And you can ask them, okay, should I go to the right or to the left to get out on the road? And the person looking at the photos can say, okay, the right one looks more relevant, so you can go in this direction because there is this moth grows on the side of the trees, and that means north, so you should go there. And on the left, judged by the photo, there is probably a swamp nearby, so you should avoid this direction. You should avoid these trees which look like this. And then you can continue your path, evaluating yourself. Should you go right or left? But you have this information from these two photos from a person who is an expert, and you can compare with a certain confidence and think, should I go right or left? Does it look like it leads to the swamp or to the road? So it's the same what are we doing on the second retrieval with our simple retrieval in the HNSW index. We're using the direction, we're using the signal provided by the big smart model. Big smart model can be anything. LLM, cross-encoder, Colbert, whatever. It sees the results of the first retrieval, just like 2, 3, 5 of them. It already makes some impression of what is inside our storage. It says, okay, this is more relevant, this is less relevant. We extract the signals from this information, from these pairs of direction, right, like go there, go to the relevance, left, not go there, not go to the relevance. And by extracting this signal, we can then traverse HNSW index into the direction which looks, from the perspective of the big model, more right. It's probably the relevant document is stored there. So the formula, which we will use on the second step of retrieval, based on this feedback, is going to be as simple as that. We just combine 3 signals, which we get from the big model, and we have 3 trained parameters, which are trained based on the pair of the retriever and our smart feedback giver. And that's basically it. We can apply it during HNSW traversal on the second step. So once again, to show the parameters that we have here. So ABC, they are trained. You usually need around 500 examples to train them because it's only 3 of them. And the parameters that you extract from the relevance feedback of the big model are here. So it's basically the direction, where would you go based on these photos in the forest, right or left. And the confidence is how confident is the big model that one example is relevant and one example is irrelevant.
Okay, so we're at time, sorry.
Oh yeah, I am finishing. So the thing is, you won't believe it, I literally threw it over the lunch, but it looks like I prepared for ages, except that I'm stuttering. So what's interesting actually? The interesting part that I tested it and it worked. And it worked in the way that the small model, which was 2,000 dimensions, a retriever, and the big model, which was Colbert, very large model, went to use this method on the second iteration. We got the recall plus of the retrieved results, which were relevant by the definition, plus from 6 to 30%. So it seemed like a really working method, which is pretty simple because you just need to put a scoring function inside your HNSW index, and then you create a method which increases cheaply the recall of the retrieved results. And we decided that we can use the simple interface like that, and probably we are going to introduce it in the next version. So it was pretty funny to try out to do a little bit research in the relevance feedback.
Thanks a lot. Thank you.